In this new tutorial, we will look at how to do data analysis using Fawn. We will start with installing a new corpus that I prepared for discussing data preparation towards analysis. And from there, we'll proceed through data queries and then reporting of our query data. And finally, what I'll do is cover the essentials for built-in analyses within Fawn. And all of those will be in separate chapters so that you can see every small step in isolation. I've prepared that small corpus derived from the Dutch CLPF corpus, so it's just a sample, so not representative of the whole corpus. And I've chosen this corpus because it is it's one of the older corpora we have within FoundBank, and so it comes with a series of small properties that are worth discussing, so as to have everything in hand when it comes to preparing our data for analysis. The first thing I will do is move my new corpus into my workspace folder. And one trick here from the welcome window is to click on that little icon that appears when you hover over your workspace folder to open it straight within your file browser or Finder. And so with this open, I will just decompress the corpus and move it into my workspace. In this particular case, I'm not installing audio data. I'm not looking for audio data. Everything we'll do here will be based on phonetic transcriptions and orthographic transcription as well. So I can close this, and now that I've moved this into my workspace, I can refresh, and the corpus appears straight within the project appears straight within the project list within that workspace. So if I click on this, I get access to my corpus sample, which is only one of the 12 kits that are documented in the original Dutch CLPF corpus. And so if we open one session, what we'll see is that the corpus is transcribed on a phrase by phrase or sentence by sentence basis. And I'm opening it here using an interface that doesn't have anything about audio support because we're not concerned with audio. And instead of that, what I'm focusing on at the moment are the phonetic transcriptions and the syllabification of those phonetic transcriptions. Which brings us to our first topic here about preparing those transcriptions and also the phoned alignments that are required for any type of analysis based on target actual phone comparison. So I will close this session, and here is one of the good steps to go through when you download a corpus from an independent source. So for example, from the FoundBank project. So the corpus gets downloaded. It has annotations for syllabification and alignment, and sometimes it could be missing those annotations altogether, in which case the symbols in the syllabification options would all be grayed out. So you wouldn't see any color there, which means your corpus has not been syllabified yet. And Fawn has a system to enable you to reset those annotations and also to check the corpus in general to make sure that your data are valid for analysis. And these functions are within the project menu. You go in the Check Sessions option, and here you can select the whole corpus. And what we'll do here is reset all the syllabifications using the syllabifier that we created to adapt to the transcription conventions of the Dutch corpus, and we'll use the simple syllabifier, so only onsets, nuclei, and codas to label consonants and vowels in the strings. And we'll also reset the phoned alignments so that we make sure that there's no spurious alignments that could have been entered by the person using the corpus previously. And it takes a few minutes, depending on the size of the corpus. It can take several minutes to run those checks, but what the advantage of doing this at the very beginning of your work is that you're starting with a clean slate, not with the transcriptions. The transcriptions are not affected by the those resets, but you get to reset your phone syllabification and alignment annotations, and so that gives you a clean slate so that you can verify all of your data without having to deal with artifacts from previous work. After all the checks are completed, Fawn will produce a report to notify you of what happened during the reset. So Fawn will tell you what phones got realigned or resyllabified. So this report is very useful, such that so that you can get to see if Fawn did anything to your corpus, and in what way Fawn did the operation. One thing very useful about the reports in this session check, just as in all of the report previews in Fawn, is that every time you have a record number listed in the report, you can click on that record number to open the example and have a look at it. In this particular case, we don't need to go and check things one by one, because we'll visualize all of our records before we do analysis. But that is also always something useful, because if you see anything in those reports and you want to have quick access to your data, you can just get it from clicking on the appropriate record. So no major warnings. This is already good news. We can close this window. And now we are reset. So we're ready to get our work done, but we're not ready for analysis yet. So one of the things about the syllabification and alignment systems, as I mentioned in the tutorials relevant to these functions, is that they offer you with a computer-based guess. The syllabification comes from a deterministic algorithm that will syllabify phones by position, but syllabification is also influenced by the types of transcriptions that appear in the strings. So for example, here we have a long A followed by a short lax E, and the syllabifier of Fawn is parsing that string as a series of vowels, so as a hiatus, and you can see this being indicated by the boundary between syllables within syllabification. Whether this is important for your research is one question. In our case, we'll be focusing on consonants, so we don't need to be too worried about that. But if you were to, if you needed to reset this syllabification and turn this into an actual diphthong, which is what I think should be the case in this particular example, then you can always right-click and select the toggle hiatus with A, and that will parse the phone in its unique syllable, in a unique syllable. And another bit of analysis here, or implication for analysis, is that we could interpret that lax E as a vocalized reflex for the target R, in which case the idea, if we really want to interpret R, like the lax E here, as the production, the child's production for what is R in the input, then we also need to reset the alignment so that these two phones get aligned one by one. So as you can see, and if you go through the data, whatever data set you have, Fawn typically does a good job at guessing alignments, but Fawn cannot replace your own actions. Here's another example concerning vowels. So we have a diphthong here that's transcribed without a ligature in the IP target, but with a ligature in the IP actual. And that has implications for phone alignment here, because the ligature will link the two phones into a single phone object, whereas if you keep these symbols separate without ligature, then Fawn will parse these phones as different phones. So if you wanted to uniformize that, this is one good case to bring up the IP map. So I do Command M or Control M on a Windows or Linux system. Then I can go and get my ligature to link my phones together, and immediately, as you'll see when I click outside of that particular box, Fawn will syllabify my form and also reset the alignment. And you'll see the magic operating here. Whereby you don't no longer have a spurious alignment between the two forms. Interestingly, that diphthong was not transcribed with a hiatus, and in this particular case either. So if you were to work on vowels, that would imply a little bit of work on fixing those transcriptions such that the IP target and actual forms follow the same conventions. But as I mentioned earlier, in our particular case, we are not too concerned by that because our work will be done on consonants. So, but here I'm just doing the work for exemplification.